This is fluid coding and AI. The privacy bug in an agent stack usually is not the final model call. It is every durable copy you made before and after it: traces, support tickets, vector chunks, tool arguments, summaries, and memory. Today, the rule is simple: sanitize before persistence, or you are cleaning up after the leak. Coding agents are observability machines. They capture prompts, tool call arguments, shell output, retrieve documents, model responses, and error traces so developers can debug what happened. That is useful, but it also creates privacy gravity. A single pasted token can land in a trace, a log export, a support ticket summary, an embedding payload, and a long-term memory. Once that happens, the problem is no longer one bad prompt. It is data lifecycle management. The privacy layer should sit before 4 persistence points: before logs and traces, before vector indexing, before support ticket ingestion, before agent memory writes. That does not mean you erase all useful context. It means raw events pass through parsing, local detection, policy mapping, and then typed placeholders or redaction before any durable system receives them. The destination should get enough structure to stay useful, but not the original sensitive span. OpenAI released Privacy Filter on April 22, 2026, as an open-weight model for detecting and redacting personally identifiable information in text. The important part is that it can run locally, so unfiltered PII does not have to leave your machine just to be removed. It is a bidirectional token classification model, not a text generator. It labels spans in one forward pass, then decodes coherent ranges like private email, private URL, account number, secret private person, private phone, private address, and private date. Regex is still useful. It catches clean emails, obvious phone numbers, and familiar key formats. The problem is that developer privacy bugs are rarely that clean. A date can be a release deadline or a private appointment. A URL can be public documentation or a private account page. A number can be a build ID or a customer account number. A password can be split across punctuation in a messy ticket. Regex sees shape. Privacy systems need context. The test suite should not be a clean list of fake emails. It should look like the systems you actually run. Use support tickets with names hidden in natural language. Terminal logs with private host names. Tool call JSON with credentials. Account IDs near harmless ticket IDs. Private URLs broken across lines. Code snippets with sample keys that should not be treated like real secrets. Then score 3 things: sensitive spans missed, useful debugging facts preserved, and benign technical strings incorrectly redacted. Logs and traces are the easiest place to accidentally preserve secrets because they are designed to capture reality. Langsmith documents multiple ways to avoid logging sensitive trace data, including hiding inputs and outputs, masking metadata, using regex, using anonymization libraries, or disabling tracing for zero retention cases. Langfuse supports client-side masking before trace data is sent to the server. Presidio has a telemetry redaction example for OpenTelemetry, Loki, Tempo, and Grafana. The pattern is consistent: mask before export, not after the observability stack has copied it. Gateway redaction is valuable, but it is not the whole privacy boundary. Langsmith's gateway documentation calls out surfaces that gateway redaction does not cover, including provider responses, data already in traces, direct API writes that bypass the gateway, platform-level ingestion, system prompts, developer prompts, and tool call arguments. That warning maps directly onto agent systems. If a tool call writes raw data to memory, or a retriever indexes raw tickets before the gateway sees anything, the gateway cannot protect that copy. For RAG, the privacy rule is especially strict: filter before chunking and embedding. Vector databases can store customer records, contracts, health records, financial data, and intellectual property. If raw tickets or documents are embedded first, sensitive text can persist in chunk payloads, metadata, caches, and sometimes in recoverable patterns from embeddings. A safer flow is raw source, parse, privacy filter, stable placeholders, chunk, embed, and then store. Retrieval still sees entity continuity, but the original private span is not what gets indexed. Support tickets are where clean privacy assumptions go to die. Customers paste passwords, credit card fragments, account numbers, screenshots, internal logs, and personal details into tickets because they are trying to get help. Zendesk's redaction documentation exists because that data can be stored with the ticket and visible to anyone with ticket access, so the ingestion point matters. Filter ticket comments, internal notes, attachments when possible, and AI-generated summaries before they become searchable support history. Agent memory needs its own control point because memory is where short-term context becomes future behavior. Even if the user message was filtered, tool outputs can reintroduce private repo URLs, customer names, credentials, account identifiers, or stack traces with personal paths. Summaries can also paraphrase sensitive details instead of copying them exactly, filter before memory writes, and treat summaries as new data, not automatically safe data. The agent cannot retrieve a secret later if the secret was never persisted. OpenAI's first-party model card reports strong PII masking numbers, with all label token F1 around 0.96 on the baseline PII masking, 300K evaluation, and around 0.974 after corrected evaluation. But the same report shows why local testing matters. On CRED data, the secret label has much weaker span level F1 than token level F1, because exact secret boundaries are hard. The model card also warns about distant context, uncommon names, regional naming patterns, benign high-entropy strings, synthetic credentials, and out-of detection is only half the system. The policy mapper decides what happens next. Emails, phone numbers, addresses, account numbers, and secrets are usually redacted by default. Private people may need stable pseudonyms when entity continuity matters. Dates need context. A release date can stay. A date tied to a person's appointment or birth date should not. For RAG-typed placeholders often preserve more utility than a flat redacted marker. The point is not to hide every noun. The point is to remove sensitive spans while keeping the developer signal. Local first does not mean risk-free. You still have to package the model, pin versions, monitor latency, decide whether failures block writes, and review false positives. Privacy filters' native labels are static, so some organizations will need calibration, custom recognizers, or fine-tuning. There is also a supply chain warning. Hidden Layer reported a fake Hugging Face repository named OpenOSS/Privacy Filter that impersonated the legitimate release and shipped malware. For a privacy tool, repository verification is not housekeeping. It is part of the threat model. The practical verdict is to build the privacy layer as a shared service, not a helper function hidden inside one prompt path. Put it before logs, vectors, ticket ingestion, and memory. Run it locally when raw data is sensitive. Use typed placeholders where context matters. Keep regex for simple deterministic wins, but test contextual cases with model-based detection. Score leakage, utility, and false positives together. And most importantly, treat privacy filtering like a critical dependency. Version it, evaluate it, and make every durable write prove it passed through the gate. If this helped you think more clearly about agent privacy, like the video and subscribe to Fluid Coding and AI. The next time your agent saves a trace, chunk, ticket, or memory, make sure the sensitive data never gets stored in the first place.